Okay, I got it. Yeah. Oh, yeah, yeah, yeah. I got it. I got it. And this is like going out. Yeah. Okay. Got it. Got it. Got it. Okay. Mm. Yes. 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 Okay. Yeah, I'm able to see. Yeah. Okay. Got it, got it, got it. Yep, yep. Okay. Mm. Yeah, I'm able to see. Got it. Yeah, yeah, I got it, I got it.
Good evening, everyone. Am I audible? Lipsa, am I audible?
Yeah, okay. This is not from Medcur. This is like from my MTech like notes which my faculty shared. So I'm not sure like from which book he took it or like not. But
Lipsa, am I audible?
Yes, ma'am.
Okay, okay. Then we can start the class. Is my screen visible?
Yes, ma'am.
Good evening. I'm Shiva Shankari. I'm a PhD scholar from IIT Madras. I'm funded by my research is funded by the Prime Minister um, Research Fellowship, so PMRF. Uh, I have been appointed as one of the TA, that is the teaching assistant for handling this course, water treatment and recycling NPTEL course. And today is the live section, session 9 I'm gonna handle. So in this entire week, first what the professor has teached, we can see it as a like very crisp glance, and then later on solve some problems. I have taken problems that are very similar to the assignment problems. One second. Okay, I have like taken problems that are very similar to that assignment problems, but not exactly with same numbers. So if you attend this class, you will get an idea how to solve those problems, for the upcoming week assignment. So it will be helpful for you to solve the assignment. So that is the main idea behind these classes. So let's start with the class. First, I would like to one second, I will share my iPad. Okay, so yeah, now it's ready. So in this entire week, that is week 9, the professor had like shared about the main topic is week 9. Main topic is tertiary water treatment. Tertiary water treatment. Okay. So, in week 9, lecture 1, he has taught like what is advanced treatment or tertiary water treatment. Okay. So, basically, what is tertiary treatment in general doing is we know there are three treatments: primary treatment, secondary treatment, and the tertiary treatment. Or the advanced treatment, also known as. So, um, the primary treatment is until the primary sedimentation tank. Primary clarifier. This is until the biological treatment or the secondary clarifier. So whatever treatment is happening after the secondary biological treatment is basically your tertiary. So what does the tertiary treatment actually do? So it ensures the secondary treated wastewater is like further enhanced for particular for particular usage in a field or something like that. Okay. So for example, um, tertiary treatment. Um, okay. Okay. So uh, for what all things we are using tertiary treatment. Okay. So the effluent from the pollutants that your primary or secondary treatment cannot remove. Okay, then we have the residual nutrients. Lipsa, can you tell me what are the nutrients that are present in the wastewater? Do you have any idea?
No, ma'am.
Okay, so so the nutrients are nitrogen and phosphorus.
Okay.
Okay, so nitrogen removal, phosphorus removal, and then we have our pathogens, pathogens disinfection. Pathogen removal is basically disinfection, right? Then we have other things like removal of emerging contaminants. Okay, so then, yep, these are the main things you will be removing using your tertiary treatment. Okay, so this was the idea that was given in lecture one. And then we can start to go in depth. Okay, okay. 1 second, sorry. Okay, then um, so in specific, if we see, the professor had taught about uh, overall theoretical stuff and specifically what are the treatments that we can use for removing specific things. Okay, so in the next lecture he covered about the biological, uh, the nutrient removal, that is the removal of nitrogen and phosphorus. Okay, so for this, for removal of nitrogen, we can use two of these methods. The first method is you can use the biological method, that is nitrification and denitrification process. So in nitrification, the ammonia gets converted to nitrite and nitrate. Then the converted nitrate is converted to uh, denitrification, is converted to nitrogen gas with the help of denitrifiers. So the nitrification and denitrification process will convert the ammonia that is in water. Nitrogen is present in form of ammonia or ammonium ion. Okay. So this ammonia will get converted to N2 gas and it will get released in case of biological nitrogen and nitrification and denitrification process. Okay. So the other form is ammonia stripping. Okay. It is a chemical process, and here the pH will be pH will be raised by the addition of lime. Okay, and then and then uh, ammonia will be removed from water. Okay, so in biological method we have the anamox process also, apart from conventional nitrification and denitrification process. Conventional nitrification. Denitrification or the anamox process. Okay. For the anamox process. So then we have the removal of phosphorus. This also can be divided into biological and then chemical. In chemical, we have the chemical precipitation, and in biological, we use phosphorus accumulating organism, PAO, phosphorus accumulating organism. Okay, so that's all about these things. Apart from that, he had discussed about the absorption types and how it's done. Then then the professor has discussed about the ion exchange process. The main difference between absorption and ion exchange is that in absorption, both are like surface phenomenon and separation technologies. But then in case of absorption, there is no exchange of ions. In case of ion exchange process, it is highly specific. Uh, the resins are designed to remove particular pollutants based on the affinity and everything. Okay, so this is very specific. Resins will be applied to remove specific ions or pollutants. Here it is. This is not exactly like engineered for like removing specific ions or something like that. Okay, so here in ion exchange, something will be exchanged from the original resin to with the pollutant. Okay, so that is the main difference between absorption and ion exchange process. Then he has discussed about the membrane filtration processes. We have the microfiltration, ultrafiltration, nanofiltration, oro process, and electrodialysis. So about each and everything, if you want to like go through quickly, just check the lecture. Now, after that, he had discussed about the disinfection and other chemical treatments. The next lecture was about disinfection. The last lecture, that is lecture number 47, was about the disinfection and chemical treatment. Okay, so this is the overall idea of all the lectures that the professor had given in this line. So now I would like to discuss few problems. Basically, I have taken only two type of problems that is very similar to the assignment problems. However, I have taken in three or four numbers so that it will be a practice for you people, and then you can like solve the assignment problem easily. Okay. So the first problem is from ion exchange. The first type is from ion exchange, and the second type is from overall like membrane technology, this carbon filter, everything. It is basically aptitude sort of problems that was given in the assignment. Nothing was like you have to remember something or anything. If you understand the logic, then you will be able to complete the problem easily. Only those sort of problems were given. So I will show very similar problems, but then with different numbers, so that it will be easy for you people to solve the problem. Okay, so now let's move to the problem. Is my screen visible? Is my screen visible? Can someone respond? Okay, I think it's visible. Okay, so the first type of problem, um, it is given in an ion exchange resin. The weight of the resin is given. Okay, so let's write the given first. Equal to 100 kg. Okay, and then we have the flow equal to 10 kL. Okay, and then we have time of operation equal to 6 hours. Then the TDS is removed from is removed equal to 800 minus 200 mg per liter. Okay, so it is basically 600 mg per liter. Okay, so now resin capacity. What is meant by resin capacity? Resin capacity is nothing but your resin capacity is nothing but your weight of pollutant removed divided by the weight of the resin. Okay, so how much a resin can remove? How much a resin can remove per unit weight of the resin. Okay, so here the pollutant is nothing but the TDS. Okay, we know how much is the TDS removed, but it is given in terms of flow. No, based on concentration. So this has to be converted to weight. Okay, so 600 is mg per liter. Okay, however, totally how much water is being treated? The flow is that will give the volume, that is liters of uh, um, is equal to concentration. We need the volume of water to be treated, volume of water treated using the resin equal to flow. You know what is the time, right? You know what is the flow. Q is equal to V by T, implies V is equal to Q into T. Anna. So if you put this equal to volume of treated is equal, volume of water treated is equal to nothing but 10 into 10 to the power minus 3. I'm writing in MLD. Okay, this is in MLD. 10 into 10 to the power minus 3 into 6 hours. 6 hours is nothing but 6 by 24 days. This is an MLD. Okay, so if we substitute everything, we will get 10 into 10 to the power minus 3 into 6 divided by 24 equal to 2.5 into 10 to the power minus 3 liters of water. Okay, so now what will be the weight of pollutant treated? Weight of TDS removed equal to 600 into 2.5 into 10 to the power minus 3 mg. Equal to 1.5 mg. Okay, this is in MLD. Okay, so this is kg basically. Because this is in MLD, so this is also MLD, it's not liters. Okay, so it is 1. Okay. So next step is it is removed by how much is the weight of the resin? It is 100 kgs, right? Weight of the resin used for 100 kg. Now, Kanu, can you tell me what is the resin capacity? resin capacity equal to weight of TDS removed per unit weight of resin used. Can you like just tell me by substituting the answers? Okay, so the answer is 1.5 divided by 100 equal to 0.015 kg per kg or gram per gram. Means like gram of TDS per gram of resin used. Okay, so this is with problem 1. Similar to this with same type but with different numbers. I have like 4 more problems. We will solve that as well so that like it will get practiced easily for you to solve the assignment problems. Then we will move to the next type in which I have some 3 problems and then we will wrap up the session. That's it. So going to problem number 2. So in this given us, let's write down the given one. Okay, so the given is problem weight of resin used 200 kgs. Flow equal to 30 kLD. Time equal to 24 hours. TDS removal equal to 1200 minus 300 equal to 900 mg per liter. To find resin capacity similar to the previous problem. So going to the solution. First we have to find the volume of water treated equal to Q into time, which is nothing but 30 into 10 to the power minus 3. This is in MLD into 24 by 24 since it is like in one day. Okay, so which is nothing but 30 into 10 to the power minus 3 million liters ml. Okay, so that is what your flow is. I mean like volume of water to be treated. Okay. Then we have to use how much is, then we have to find uh, using this data how much is the weight of pollutant input 30 into 10 to the power minus 3 into 900 we will get in kg. Okay, which is equal to 27 kgs of TDS. So now resin capacity is equal to weight of TDS removed by the resin weight of resin used, which is nothing but 27 kgs divided by 200 kgs, which is equal to 0.135 gram of TDS can be removed per gram of your resin. Okay, so that is the thing. So now next problem, we have the third problem. It is also very similar to this problem as I have told. So um, Kanu, can you try to solve this problem and tell me the answer? I will wait for 2 minutes. Kanu, Kanu, are you there in the meeting? Okay. So problem number 3.
Hello, ma'am. Telling me something.
Yeah. Can you try this problem? It is very similar to the previous two problems I have taught. Can you try this problem?
Yeah, sure, I can do it.
Yeah,
Yeah.
yeah, yeah. I'll give 2 minutes. I mean, like, I will give 5 minutes time. I will wait and then we can check the answer. Okay?
Okay. The question is, what is the question, ma'am?
So we have
This
to
is
determine the
okay.
resin capacity. Okay? So given is the weight of the resin, the flow, the time, and how much TDS is removed. These are the things that are given.
Okay.
Okay? So you have to find the
Yeah.
resin capacity. What is the formula for resin capacity? Any idea?
Resin capacity. How much TDS is removed? For how much of resin is used?
Yeah, exactly. Okay. It is very similar to the previous problem. Okay, so we need to know what is the weight of TDS that is removed by the resin divided by the weight of the resin used. Okay, we know what is
Yeah.
the weight of the resin used here. It is given in the problem. It is 250 kg. So we need
Yeah.
to determine how much is the TDS removed in terms of weight. Okay, so
Yeah.
we know what is the TDS concentration, okay, removal. That is, it is removed from 1800 to 600. So it's basically 1200 mg per liter. That will be
Right.
the concentration of your TDS. You have been given with the flow. You have been given with the time of operation. So from flow and time of operation, you will get the volume of water that is treated, right? So
Yeah.
you know the volume of water and you know the concentration. Then you just multiply and get the weight of TDS removed. Okay, and then just plug it in the formula.
Yeah.
Is that okay? The protocol is fine, right?
Yeah. Yeah, ma'am. Yeah.
Okay. So I'll give now. I'll give 4 minutes time. You can like try to like solve. Okay.
Okay, then, but I have to then write down the this. Okay, okay, let me try. But why I will get the problem? It's not. I'm not getting it in the screen.
What? If not,
Problem.
problem,
Problem statement.
problem you are not understanding.
No. Problem statement. It's not visible.
Oh, not visible. Oh my God. Not
Yeah.
visible. Oh, my screen is visible, right?
Yeah. Your screen is visible.
Okay. Now is it visible? Resin 250 kg.
No,
Not visible. Oh,
no.
for me from iPad it's visible. Okay, I will tell the question. You just write it. Okay.
Yeah. Just tell me.
Okay. So the resin weight is 250 kgs.
250 kg. Okay.
Yeah. And the flow is 50 KLD.
50 KLD.
Yeah.
Okay. Okay.
The time is 8 hours.
Time is 8 hours. Okay.
TDS is 1800 to 600. It is reduced from 1800. Initial TDS is 1800.
To 600.
Yeah, exactly.
Okay.
We
So
have to
mg per
find the
liter.
resin capacity. Yeah.
Okay. So capacity I have to calculate. Okay, I'm doing it.
Okay. Yeah. I'll
Okay.
just come from the washroom. Just 2 minutes. Okay. You can
Okay.
just
Sure.
try. Yeah.
Okay.
You can
No
just
issue.
try by the time. Okay.
Okay. Okay.
Kanu?
Yeah, ma'am.
Um, okay, the answer is actually 0.08. I'm getting. Maybe there is some problem with the convert. Is my iPad visible?
Yeah, ma'am. Visible.
Yeah. So, okay, let's substitute the values. Okay, in the same problem itself, like I have wrote with purple color. Okay, so
Point 0.0250. Okay, let's see.
20 divided by 250, I'm getting. How much are you getting? The
Just can you
numeric,
repeat, please?
huh?
Can you repeat, please?
I'm getting weight of TDS to be removed by the resin as 20.
20.
Yeah,
So TDS removed is I have got 20,000 kg.
20,000 kg.
Mg. Oh, I am sorry. I am sorry. That unit has been, I have not 20,000. This is 20
Yeah,
kg.
exactly. You might
Yeah,
have
yeah.
made small mistake. Yeah, yep, yep.
20. Yeah.
Yeah,
So
so the
20 divided by 250. Point
uh,
zero 0.08. Yeah, yeah.
yeah, okay. So the answer is 0.08.
Yeah, yeah, ma'am. 0.08.
Okay, it's
Okay.
easy only. Like, yeah, I have very similar problem, two more problems. We can solve that so that like for you, like it is very same problem but with different like numericals, like the three problems similar to the three problems. We can solve that so that like your assignment problems will be very easy for you. There are only two problems in the assignment, so one is of this type and the other one is of some other type. So I this one you try to solve this problem. um
Okay, ma'am.
Resin, is my screen visible?
Yeah, yeah. This is visible.
Okay, so the resin weight is 80 kg, flow is 8 KLD, time is 10 hours, TDS removed is 600 mg per liter. We have to find the resin capacity. Okay, so it's very similar. Okay,
Okay, okay. Okay, ma'am. I can do it.
okay.
Okay.
I'll wait. I'll also solve meanwhile, but then like I will wait also. Okay.
Okay, ma'am. Sure, sure. Six hundred. This is mg. Ma'am, this is 0.025.
1 second. Okay, divided by 80. Yeah, exactly. I'm also getting the same answer. Okay, so resin
Yeah.
capacity. I'll just share the solution also. Yeah, yeah. Resin capacity is equal to 2 by 80, which is equal to 0.025. Yeah, gram of TDS per
Per gram
gram of
resin.
resin. Yeah. Now
Yeah.
we will move to one more problem I have that also like we can solve. Now it is becoming easy. See, yeah. So yeah, the next problem is
That time my conversion of unit was wrong. I
yeah, yeah.
converted mg from kg by dividing it by 1000.
yeah. It's okay. Yeah, it's okay. Yeah. Now this problem, yeah, we can solve together. Resin weight is equal to 120
So
kg. Okay, so volume of water equal to 15 kld, 15 into 10 to the power minus 3 into
uh,
20 divided by 24 is equal to
12,500.
okay. Yes, weight equal to 1000 input 12.5
12,500.
okay. So this and this will get cancelled. So 12.5 kg is TDS weight. So resin capacity,
12.5 kg. So 12.5 by 120.
yeah, 12.5 divided by 1.
0.104.
Yeah, I'm also getting, yeah,
Yeah.
excellent. Yeah. So this problem is solved. Okay.
Yeah,
So
ma'am.
this type is solved. Apart from this, one more type is present. Okay. It is basically aptitude type question. It's easy only, we can solve. I have three problems similar to that. So we can like solve those problems. Okay.
Okay.
Okay. So, mm, one second, I'll have some water. Mm. A 300 KLD effluent treatment plant is treating its water through sand plus carbon filter, then with UF and RO. Okay. The TSS and TDS at different stages are um, given. Okay.
Yeah.
So, yeah. So, if we see in this problem, we have like three treatment units. This is the filter, carbon sand filter. The next is the UF.
Are you making some sketches, ma'am?
Is it visible?
No, your screen is visible. It's showing the problem statement only.
Okay. Oh, my iPad should be visible.
Ma'am, can you allow me 1 minute?
Yeah, sure.
Just a minute, ma'am. Yeah, ma'am. Sorry.
No problem. Okay.
Hello.
No problem. Yeah, sure.
Yeah.
Okay. So, uh, is my iPad visible now?
Yeah. Yeah.
Okay. Okay. So we have this carbon sand filter. Then we have our ultrafiltration unit, in which ultrafiltration we have permeate and return and reject. Okay.
Yeah.
Maybe we can keep this as reject, and then we have our permeate, which will be entering our RO unit. Okay. So
Yeah.
at this stage, the TSS equal to 25 mg per liter. The TDS equal to 8000 mg per liter. At this stage, the TSS is completely removed, it's 0, and the TDS is equal to 500, oh sorry, it's 5000 mg per liter, and here we have the reject and
Yeah.
permeate, and then here we have our TSS equal to 0 and TDS equal to 200 mg per liter. Okay, so this is
Yeah.
the given data. Hmm? Now we have to and also it is given that in US the permeate is 96% and reject is 46%. So let's see, this is the flow of contaminants. Okay, so now let's see the flow of the water. Okay, so initially 300 KLD is coming in. Okay, 300 KLD. Here it's gonna be 300 KLD again because there is no reject. Okay, there is no reject, so 300 KLD. But in UF we have reject and permeate. Okay, so the permeate is 96%. Okay, so permeate is nothing but 300 into 0.96. Okay, so which is nothing but 288. So here it's going to be 288 KLD, and the remaining 288 minus 300 is nothing but I think it should be 12, right? So,
How much reject is there in UF?
4%, 4%.
Okay.
96% it is
Permeate.
permeate and 4% is the reject. Okay, so here it's going to be 12 KLD. Okay, when it is entering the RO, it's going to be 288 that is fed to RO, and in RO we have the permeate as 65% only. Okay, so 288 into 0.65. Okay, that will be
Yeah.
our final treated water in terms of quantity. Okay, volume of water treated will be this much.
187.2 liter.
Okay,
KLD. Sorry.
okay, and the
One
reject,
187.2 KLD.
yeah, 187.2 KLD. Okay, so yeah, we have almost answered one question in this. The total RO treated water available in KLD is nothing but that question we have answered already. Okay, so that's how we have to answer this question. Okay, so
Okay.
187.2 KLD. Okay, so now
Okay.
what are other things that is asked? The total solids removal efficiency at the filter. Okay, that is the filter. Okay, how much is in percentage total solids. Okay, so in carbon filter. Okay, so first question is in carbon filter. In carbon filter, what is the someone has entered the name. In carbon filter, what is the efficiency of total solids removal?
Solid removal.
So
Yeah.
the efficiency of total solids removal is nothing but what is the total solids uh, removed divided by what is the total solids in the influent. Okay,
Yeah.
so total solids removed divided by total solids entered. Okay,
Okay.
okay, one data is missing here. We need to know what is the total solids entering the
In
carbon filter. Yeah, yeah, yeah. So we can like, yeah, I will give the data for that. The okay, I will give the data for this line. That is what is required, right?
and otherwise we can calculate from UF and RO for UF and RO.
Yeah, that also we can do. Yeah, that we can do. But then, yeah, this question was asked in the assignment. That's why I want to make sure that this is like, I mean, like, you know the methodology to do. I think you know the methodology, but then the class is recorded, right? So, like, if someone is not attending the class, like, they need to know, right? So, I will just give some data and then, like, we will find this total solids removal efficiency and then go to other subdivisions as well. Is that
Sure,
okay?
ma'am. Yeah, yeah.
So we can have the total solids entering, that is TSS entering is equal to, we can keep it as 250 mg per liter, and then the TDS entering is equal to 10,000 mg per liter. Okay,
Okay, ma'am.
so if we see total solids removed, it's going to be TS removed
10,250
plus TDS removed divided by
with
TSS entering plus TDS
10,000
entering, right?
plus, yeah, ma'am. 8025
Which is
divided by
nothing
10.
but 250 minus
21.7%.
okay, plus TDS is nothing but 10,000. This is 10,000.
21.7%, ma'am, is coming.
Okay, amazing. 1 second. 10,000 minus 8,000 divided by 250 plus 10,000, which is equal to 225 plus 2,000. Just is equal to 21%, right? Yeah, 21%. Okay, so this is what is the first subdivision. The second subdivision is total solids in the UF reject in mg per liter. Okay, so in UF reject, we have to see what is the total solids present. Okay, so let's draw UF separately.
Can you repeat the question, ma'am?
Okay,
Next question.
the total solids in UF reject.
Total solid.
Total solids present in UF reject. Okay, so
Okay.
let me draw this UF
So 4
separately.
percentage is reject. That means 96 percentage permeate.
Yeah, 96 percentage is permeate. Yeah,
Okay.
okay. So we have to
Yeah.
find the concentration of total solids in the UF reject.
Okay.
Okay.
Concentration
So
of.
first let's draw the UF separately. Okay, for like clear representation and like understanding.
Okay,
So
ma'am.
this is entering is 300 KLD and then it is going to become 288 KLD
Yeah.
and 12 K. Okay, and here TSS is equal, oh yeah, TSS is equal to 0, TDS is equal to 5000. Okay, so and what is entering the RO? I mean, like, yeah. So here it's going to be, we have to find what is the TDS over here. Okay, I mean, like, concentration of total solids.
Yes. But
No, no,
just
no.
a minute.
I'm sorry. This is the output of. I'm sorry. This is the output. Yeah, 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 yeah. I'm really sorry about that.
Yes.
Yeah. So here from the carbon filter we are getting TSS. equal to 25 mg per liter, and then we have the TDS equal to
Is
8000 mg
8,000.
per liter. Yeah. Okay. So, uh, and after this, in this 288 KLD, we have 5000 mg per liter in the permeate. Okay. So we have
Yes.
to find what is in the rejected retentate. Okay. So in the retentate, you will have TSS completely. Okay. So the TSS is completely rejected by the UF system. Okay. And then you will have this little bit of your this one removed also. Okay. Um,
3,000 mg per liter, the TDS.
exactly. Yeah.
So
Exactly.
can we do in summation, because it will not make any difference whether it is TSS or TDS. Total solids coming in and total solids going out. So the difference is the difference should be the reject.
Exactly. We can do the mass balance. Okay.
Yeah.
Because see here, it is nothing but we can do the mass balance separately for TSS and TDS and then find the total solids present in the reject. Okay. Because we
Yeah.
know the flow. Okay.
Yeah.
Q1 we know, C1 can be taken as TSS in case 1 and TDS in case 2. Okay. Similarly, we know Q2 and then this is Q3. Okay. So for case 1, for total suspended solids, if we see, we have 300 into 25 is equal to Q3 into X plus your 288 into 0. Okay, so this is going to become 0. So your Q3's value is 12 KLD. Okay, so if you substitute, X is equal to 300 into 25 divided by 12, which is nothing but 300 into 25 divided by 12. 625. Okay, mg per liter
Okay.
of TSS is present in reject. Okay, if if we do the similar thing to TDS, for
Can
TDS,
I interfere, ma'am?
yeah.
Yeah, yeah. So we are doing this for TSS and TDS.
Yes.
But the question is asking total solid. So can we do it in terms of total solids
Yeah,
for
we
this
can do. We can just
C1
add
we
it
can,
at the end, right? Total solids.
yeah, for C1 we can sum this TS and TDS, and for this C2 also we can sum this TSS and TDS.
Yeah, I think we will get the same answer. Yeah.
Yeah.
Yeah, we can do like that also. Yeah, this one was easy for me to understand, so I just did it this way. But yeah, I think we will get the same answer only. Yeah,
Okay. 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 No issue, ma'am. Yeah.
we can try that way also and check, cross check how like it works. Yeah, I think it should be correct. I don't think any issue should be there. Okay, because anyway we are going to
Yeah.
add at the end.
Yeah. Yeah.
So we have our TPS is equal to 300 into 8000 equal to 12 into x plus 5000 into 288 implies x is equal to, it's going to be 300 into 8000 minus 5000 into 288 divided by 12, which is equal to, it is coming as 80,000. Oh my god, that's too high. But yeah, it's reject, right? So we can expect that much. Yeah, 80,000 in per liter. So in total, guys, total solids,
50,000.
check, okay.
80,000 plus 625 है ना मैम?
Yeah.
So can I ask a question, ma'am, please?
Yeah, sure.
Yeah, yeah. This incoming total solid is 25 mg per liter and 8,000 mg per liter.
Yes,
And so, but the reject is 80,625 mg per liter.
yes.
So total solid coming in the system is 8,025 mg per liter. But total solid reject as a result is 80,000. So how
Because
it is possible?
because
Yeah,
in the permeate we have the permeate and the reject concept, right?
yeah,
See here, in the UF, inside a UF, what is happening? UF is going to um
there is some
US is going to
contact.
concentrate your pollutant.
Yeah,
Okay,
yeah,
concentrate. What is going to happen is one phase will remove something, and the other phase will be concentrated, right?
yeah,
So the concentrate has this much values.
yeah.
Are you getting my point? It won't be like your total solids inlet is greater
Okay,
than
okay, okay. Yeah. Sure,
yeah,
ma'am.
it
Sure,
won't be
ma'am.
like
Because
that.
the
We have the volume of
yeah, yeah,
water also to be considered, right? That's why we have used the mass balance.
yeah. That water part is reducing.
Yeah, in
That
less,
concentration is
yeah, exactly. In less water, you have like added more salts. That is the thing.
yeah,
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 similar to
yeah,
that.
yeah. Okay, ma'am. Okay,
1 second, we will try
okay.
this way also, like the way you told, right? Just adding and doing. We will try that way also and see what is the answer that is coming. I have written in the purple color, right? I will just solve and tell you. 300 into 0.025 plus into 13,000. Where did this 13,000 come from? 3 into
300 KLD multiplied by 8,025.
no, I think that doesn't come properly. No, I think which I told will be like more appropriate, I guess. And doesn't make any like mm, we have to do the mass balance separately, Kanu.
Yeah, yeah.
So yeah, okay. So yeah, that's how like this subdivision works. Okay, and then next one is TDS level and RO reject. Okay, similar to this, we can like do it for the RO system. Okay, so now we have done for the UF system. Now let's draw for the RO system. Okay, so in RO, if we see this diagram, the starting diagram, we have 288 KLD entering and then 187.2 KLD outgoing. 288, 187 point, our 65% is only the permeate, right? So 288 into 0.65. Which is nothing but 187.2. Okay, and the reject is basically this is KLD. Reject is 35%. So 288 into 0.35. If we will get 100.8. Okay, so
Yeah.
now so now what is entering is here it is 5,000.
100.8 and 187. Okay.
And then here it is 200 mg per liter. Only TDS we have, only TDS. We have to find what is the TDS in reject. Okay.
Yeah.
So similar to that, if we apply the mass balance concept, it is 288 into 5000 equal to 100.8 into x plus 200 into 187.2 implies x is equal to 288 into 5000 plus 200 into 187.2 divided by 100.8. 13,139.14.28 mg per liter. Did you understand?
Yeah, yeah. 13,914.28. Yeah. 13,000.
Mm. And the last problem, the total RO treated water available in KLD is nothing but 187.2 KLD.
Yeah, yeah.
Okay, so this is done. So with this same type, I have two more problems.
Ma'am, can you show the question?
Yeah, yeah, sure, sure. One second. Is it visible?
No.
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 It is shared, Kanu. I don't know what is the problem. Wait, let me just unshare my iPad. iPad is not shared. My screen is visible only. From other thing also, I'm able to see my screen is visible.
Yeah,
Uh,
now it's visible.
okay. Or shall I post the question in the message as a snipping shot?
Yeah, sure.
I'm not able to paste the question. Is now the screen is visible, right?
Yeah, 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 ma'am.
Okay. You can see it and then like tell me if you have any doubts.
300, 10,000, 200. Total solids. These are possible to do. Yeah, that, but the percentage of rejects and all, okay, it is there. Okay, ma'am. No issue.
Okay. So now we
Yeah,
will move to the next question.
yes, yeah.
It is very similar to this question. I will give the data. What is the entering thing into the carbon filter so that
Yeah.
like we can just solve this question also. Okay, I will just type it.
GF, then F.
audible, Kanu?
Yeah, yeah, ma'am.
Okay. Can you solve this question? I will also solve simultaneously.
Yeah, but that this data for entering the MGF,
This is
the
okay.
TSS and TDS,
Yes.
and US
Okay.
per.
I will solve. You see it, and then next problem you can solve. Okay.
But I can do, ma'am.
Okay. 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 I
I
will also
can.
do simultaneously. Okay.
Yeah, yeah. But 94 percentage. Yes, that is 55 percentage. This is 55 percentage. Total solid amount, total solid, total RO water. Total RO water, that means MGF is coming this much. 500 KLD. So 500 KLD. So 500 into 0.94 into 0.55. 258.5. So last answer is, ma'am, 258.5 KLD.
Okay. 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 I am doing from the first subdivision. Um. Yeah.
Okay.
Okay. We will like see. Um. We will discuss the answer. Okay. Yeah. Once
Sure,
I'm
sure, sure.
solving, we will discuss the answer. Yeah.
Yes, yes. Where can I get this data that this TSS is 15 mg per liter and TDS?
Okay. Okay. I will share the screen. Okay. Is my screen visible now?
Oh, okay, okay, okay. TSS 15 and TDS is 7,000. Okay. Mg per liter. No, yeah, that's okay. This TSS is 0 per minute and TDS is equal to 4,000. TSS equal to 0 and TDS equal to 100. I've got all these things. So TS removed by TS removed by MGF percentage. TSS equal to 300 into 80. 30.4067%. Total solid in the UF reject. Total solid in reject. TSS. 6% reject. TKL 30 into X plus 70 into 50 minus 50 TSS TDS TDS again 500 into 7,000 4,000 was X equal to 500 into minus 470 into 2,000 divided by 30 54,000 total solid into 250 54,250 mg per liter. Now the TDS auto reject TSS 00 TDS আছে তাহলে 470 into 2 equal to 40 percentage 45 470 7.5 470 into 4,000 equal to 7.5 into x plus TDS which are 100. 470 into minus 258. Eight seven six seven. Madam, I have got it.
1 second, Kanu. Only 1 second.
Yeah.
I'm just solving the last thing. Only 1 second.
Okay.
So,
Okay.
0.55 into 100, 7, 6.61. Okay. Shall we discuss the answer now?
Yeah.
Okay. So for the first subdivision, let me share my iPad.
That efficiency.
Yeah. That
Yeah. That
efficiency
is 30.4067%.
35. I was getting something else. 1 minute. Maybe I made a mistake. Let me just check. It is 80 minus 15 plus 2000. Is because here it is 8000 divided by 0 plus 80. Okay.
No, why 2000, ma'am? This is 3000, no?
3000. Oh,
TDS is 8000. TDS is 7000, I think. This TDS, can you go to the problem statement?
yeah, yeah, sure, sure. Oh, it's 7,000. Okay. I'm sorry,
Yeah.
I'm sorry. Yeah, okay. Then
Yeah.
you should be correct. Yeah, it should be, this should be this much. Okay. Yeah, this should be 7, right? 0 to 6,000 plus 65 divided by. Yeah, 30.4 percentage. I'm getting 30.4 percentage. Okay. So for next
Yeah.
one, are you getting total solids as 54250?
54250. Yeah.
Yeah. Okay. Then for third subdivision, is it 8,000?
766.67.
Yeah, exactly. And then for last one, it is
Point, point
258.5 K.
five.
Yeah. Okay.
Yeah.
So that's it. Yeah. Yeah, so yeah, these two types of problems were there in the assignment problems. We have one more, I have one more problem very similar to this. If you want, we can solve. Yeah,
Yeah, we can.
yeah, sure. I will just give the inlet concentrations for the carbon filter and then we can solve and then discuss the answer similar to this. Okay.
Sure, ma'am. Sure.
So 70, we can keep it as 200 and then this one as 12,000.
Then
You
skin is
can,
not.
okay, 1 second. Now is it visible?
Yeah, yeah.
Okay, we can solve this problem and then we will discuss. Okay, after solving. Okay.
Sure. GF, DF, This is 250 KLD. So this is carbon filter TSS 400. TDSS.
Kanu, did you complete it?
Yeah, ma'am.
Okay. Shall we discuss the answer?
Yeah, sure.
For first one, is it 21%?
21.89%.
Yeah, okay, amazing. For second one, is it 123,666.67 mg per liter?
Yeah, 123,666.67.
Yeah, exactly. For third one, 15541.8 mg per liter.
I have got 15593.68.
Okay. Yeah, I think it's close by. Maybe I might have made some calculation mistake. That should not be a problem. Yeah. And for last one, it is 150 kl.
0.35.
Ah, okay.
Yeah,
Yeah.
yeah,
Yeah, I have approximated to 150. Yeah, you have
yeah,
taken
yeah,
point
yeah,
five. Yeah,
yeah,
so that's why we might have got different answers.
yeah.
Yeah, okay. So that's all for today's class. And yeah, did you find it like fine? How was the class? Was it like okay?
Yeah, ma'am, it's fine. Yeah, it's
Okay, okay then. Okay
yeah,
then.
fine.
Thank you so much for attending the class. Yeah, we will
It's
meet.
very much helpful
Yeah,
because now I can do all this.
yeah.
Thank
There
you,
are
ma'am.
two. Yeah, exactly. There
Yeah,
are
ma'am.
two problems
Thank
in
you very much,
assignment
ma'am.
with this. Just two type only, so you can solve it. It will be very easy for you. Yeah,
Yeah, yeah, ma'am. These two was very much similar.
yeah. You will have
That that
exactly.
is
Yeah.
that is
Yeah, that's why I took this problem. I just changed the numbers and I like repeated the same problem so you can just solve it easily.
yeah, yeah, ma'am. Yeah.
Thank you so much, Kanu, for attending the meeting. Thank you.
Okay. Okay, ma'am. Thank you very
Bye
much.
bye.